Every year, Chrysler Corporation automobiles and trucks enter the marketplace with new features for prospective customers and new challenges for service technicians. Usually, though, the average service technician doesn't get into a major overhaul of a car until it's a couple of years old. Take brake reconditioning, for instance. The 1971 service manual is probably more in demand than the 1973 service manual. The 1971 models have been driven for thousands of miles, and the brake linings are ready for replacement. So rather than discuss the 1973 brake systems in great detail, let's backtrack a few years and recap some of the things you're more likely to run across during a normal workday on past models. Chrysler Corporation vehicles either have drum brakes front and rear, or disc brakes on the front and drum brakes on the rear. The two brake systems are similar in that they both begin with brake pedal effort to transmit a hydraulic force to the hydraulic cylinders at each wheel. This force in turn pushes the brake shoes or pads against the drums or discs to slow or stop the car. For a complete, detailed explanation, see the Master Technician Service Conference sessions covering the dual hydraulic brake system, disc brakes, floating caliper disc brakes, brake hydraulics, and disc brake service roundup. Let's get into specific differences between drum brake and disc brake systems. The tandem master cylinders have two fluid reservoirs arranged one behind the other. The rear reservoir supplies fluid to the primary piston, and the front reservoir supplies fluid to the secondary piston. The primary side of the master cylinder provides pressure to the front wheel brake cylinders, and the secondary side of the master cylinder provides pressure to the rear wheel brake cylinders. This is a very important point to remember. The secondary side of the master cylinder always supplies pressure to the rear brakes on passenger car models, and the rear brakes on passenger car models are always drum brakes. Some trucks equipped with disc brakes use a master cylinder that provides pressure to the front disc brake from the secondary side of the cylinder instead of the primary side. Trucks with drum brakes have conventional master cylinders. Okay, when you take a master cylinder used for drum brakes front and rear apart, look for a residual valve behind each of the outlet port fittings. Use an easy out to remove the valve seat. The residual valve and spring are behind the valve seat. Now let's look at a master cylinder used for disc brakes front, drum brakes rear. Notice the secondary outlet port, which supplies pressure to the rear drums as a residual valve, but the primary outlet port, which supplies pressure to the front disc brakes, does not. Secondary does, primary doesn't. Here's why we need a residual valve for the drum brakes. When the brake pedal is released by the driver, the return springs begin retracting the brake shoes. At this point, there is more pressure in the wheel cylinder than there is in the master cylinder, and the fluid forces the residual valve off the seat. When the pressure in the system and lines drops to approximately 15 pounds, the spring behind the residual valve pushes it against the seat. The residual pressure in the lines and the wheel cylinders keeps the lips of the wheel cylinder cups expanded, so they press outward against the wheel cylinder bore. This prevents air from being sucked past the wheel cylinder cups and into the hydraulic system when the brake pedal is released rapidly. Disc brakes have a retracting seal instead of return springs to draw the lining away from the disc when the brake pedal is released. The seal around the piston pulls the piston back into the cylinder bore to break the contact between the lining and the disc. If a residual valve was used in the primary side of the master cylinder, the residual pressure would prevent the seal from retracting the disc brake pad and cause the brakes to drag. That's a good point to remember if a customer complains of dragging front disc brakes. Remove the line from the primary side of the master cylinder and make sure a residual valve has not been installed behind the outlet port fitting. Be sure to bleed the brakes at the front wheel cylinders after you do your checking and reconnect the brake line to the primary side. 10 years ago, the only hardware between the master cylinder and the wheel cylinders were the brake lines and a couple of T's. The dual brake system and the introduction of disc brakes changed all that. Since the front and rear brake hydraulic systems function independently in the dual brake system, a hydraulic system safety switch is used to warn the driver if one of the hydraulic systems has failed. See the reference book for more complete details. A metering valve is used to delay the action of the front disc brakes until the rear drum brakes can take hold. To check the metering valve, have an assistant push on the brake pedal while you watch the valve stem on the metering valve. The valve should move when the brakes are applied. Another valve, the proportioning valve, is used on some models for the rear drum brakes when disc brakes are used in the front. During hard stops, the front disc brakes require more pressure. The additional pressure required would cause the rear drum brakes to lock. So the proportioning valve is connected between the master cylinder and the rear wheel cylinder. The proportioning valve is designed to reduce the pressure to the rear wheel cylinders. See the reference book for testing procedures. You've probably noticed during the course of your work that some cars combine the safety switch, metering, and proportioning valves. Many of these combinations look alike, but don't settle for lookalikes. Check the part number before you replace combination valves. Getting into the habit of making a quick preliminary check of brake components before you begin a brake system overhaul can save you a lot of time in the long run if you know what to look for. Look at the level of fluid in the master cylinder. If it's down, you'll know to check for leaks in the system. If the pads are worn thin, the fluid in the primary reservoir may be low. This, of course, would not mean a leak. Check the fluid for contamination. Draw off some fluid and put it into a clean glass jar. If there's a separation of the fluid in the jar, the fluid has oil mixed with it. Flush the system completely before you begin work. Before you begin work. If you wait until after you overhaul the system, the rubber seals will get contaminated when you replace the fluid. This rubber seal was put into this container of oil to demonstrate what oil can do to rubber. It was originally the same size as this one. Brake fluid absorbs water like mad right out of the air. Water lowers the boiling point and can cause serious problems. Brake fluid contamination can begin long before you use it for a job if someone leaves the lid off the can. Incidentally, if you use a pressure bleeder and there's a metering valve in the system, the valve must be held open while you pressure bleed the system. 69 models with floating caliper disc brakes have a metering valve which is held in manually while the brakes are bled. Current metering valve stems must be held out with a holding tool to override the valve's shutoff action. Use special tool number C4121. Remember, under no condition should a wedge or block be used to hold the valve open. This can cause the diaphragm to rupture, which results in the complete loss of front brakes. It's important for the write-up man to note on the repair order if the customer has been having any unique problems, such as grabbing brakes, chatter, and so forth. For example, brake chatter can be caused by overheated areas or hard spots on the drum surface, which causes uneven friction. Irregular, oval, or heat-spotted brake drums can usually be machined to restore the friction surface to specification standards. Remember to take off only as much material from the drum surface as needed to clean up the irregularity. Never enlarge the brake drum diameter more than 60 thousandths of an inch over the standard size. Incidentally, all drums since 1972 will show markings indicating the maximum diameter of the drum. For instance, a 9-inch drum will have a marking of maximum diameter, 9.090. This marking includes 30 thousandths for allowable drum wear beyond the recommended 60 thousandths of drum refacing. After machining, be sure to break up any machining pattern with sandpaper or emery cloth. Wipe the drum absolutely clean. Remember, even a small amount of oil can change the coefficient of friction of the lining material. By the way, don't use an air hose to clean drums or the support plates. The asbestos in the lining material can irritate your lungs if you breathe it. You can eliminate some complaints of chirping brakes if you take the time to put platform lube on the support plate contact areas. Be sure to use recommended lubricant, Mopar 2932-524 or equivalent. It has high temperature stability and doesn't wash off. There have been some complaints that 9-inch brakes are noisy. The fix for this complaint is a set of weights which bolt to the brake shoe. See the reference book for details. One sure way to get yourself in trouble is to replace a brake system part with one that isn't exactly like the one you took off. That goes for using the right rebuilding kit when you do an overhaul job too. Double check part numbers. When you're working on the rear brakes, check for leaks around the rear axle seal. Even a small leak can lead to lining contamination. Remember, a perfect reconditioning job can be ruined right here. Torque the stud nuts too tight, and you'll distort the drum. Always give the parking brake a thorough going over. Check the strut bar for free play, lube all pivot points, and adjust the parking brake after adjusting the service brakes. Now let's get into disc brakes. The first disc brakes available for production were the fixed caliper type. 4 pistons push the lining pads against the rotor. Next, the floating caliper brake was developed. 1 large piston and linings with a higher coefficient of friction do the work of 4 smaller pistons. The sliding caliper disc brake is similar to the floating caliper brake, except the caliper slides in integral machined guides when the piston exerts force on the caliper. One of the most important things to remember is to use the right pads for each type of brake. Some linings are harder than others, so using the wrong ones for the job can cause trouble. The fix for brake squeal at low speeds caused by pad vibration is explained in session 72-4, Disc Brake Service Roundup. Briefly, the outboard pad is cemented in place with cycle weld cement. It has been found that if the inboard pad is also cemented to the piston face, vibration noises are further reduced. The cement acts as a semi-flexible insulator. Well, that about covers it for this session. As you probably know from past experience, it's the little things that can come back to haunt you, the terrible trifles. Get into the habit of looking for things like small leaks that grow into big problems and take care of them right then. Remember to read the reference book for this session for additional brake reconditioning information.